Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker. Chapter 12, part 2. All right, we're going to talk and remind ourselves a little bit about the partitioning of variability in the multiple linear regression model. Remember from last time that the sum of squares total is equal to the summation I equals 1 to n of the yi's minus the y bars quantity squared. And that's equal to the sum of squared errors. Remember, those are our observations, yi minus yi hat squared. And then our sum of squares due to regression, which is the summation I equals 1 to n of our yi hats minus our y bar squareds, the SSR. So SST is our total sum of squares. That's the total variation in y. SSE is the sum of squared errors. That's the part of the variation in y that is unexplained by the model. And then our sum of squares due to regression, that's the part of variation in y that is explained by the model. So if we want to, we can calculate the coefficient of determination. That's r squared. That's the ratio of SSR divided by SST. Using the formula above, we can do SST minus SSE equals SSR divided by SST. So remember, the larger this ratio, the better the model fits the data. R squared measures the proportion of variation in y that's explained by the linear regression model. So remember, R squared is between 0 and 100%, or similarly, between 0 and 1, right? So the better the model fits the data, that R squared will be approaching 1 or 100%. And the worse the model, that R squared will approach 0.